Today I'm going to be talking about irrigation and water savings. In the world we live in, especially in Utah where I am, it's very important to be more conscious of our water. We don't have a lot of it, and it's good to save it. Even though Utah's water is fairly inexpensive, we should still be good stewards of the earth and make sure that we save as much water as we can. So most people uh, have their regular controllers that came with their house. They set it and they forget it. And that's the same rate from spring through summer through fall. All year long, you're irrigating at the exact same rate and you're wasting water, because usually if you set it and forget it, you're setting it at your summer rate when the temperatures are hottest. And if you do that, then you're overwatering in the spring, you're overwatering in the fall, and you might even be overwatering most days of the summer. So something you can do to combat that is to get a smart controller. Smart controllers are pretty sweet. They will calculate the weather outside and do the math necessary to figure out how much water you need to actually put on your lawn based on local weather data. And it will help you to automate your system so you don't even have to really mess with it too much. You can usually control it from your phone, and that's a really easy way to save a lot of water. We're going to do what's called the rule of halves, and I'm going to talk about the rule of halves and something called MAD water and plant available water. We're going to go over all of that right now. The rule of halves basically is this. You have a soil, and if you want to use this chart to help you visualize it, it's kind of helpful for me. But let's say you have a soil. You cut it in half. Half of this is going to be like the actual soil, and the other half is going to be the pore spaces, or the spaces in between the particles of soil or clay or silt, and that's the area where water can be. So let's say, for example, you have 1 foot of soil, but you're actually only looking at a 6-inch rooting depth. So you know what, let's forget about this for now. Let's start with the 1 foot of soil. You have 1 foot of soil, and 6 inches of that is going to be the actual soil, the physical soil, and the other 6 inches is going to be pore space. So that's going to be the first thing. You got 1 foot total. You're going to have 6 inches on this side of soil and 6 inches over here of pore space. So that means like the maximum amount of water you can have in 1 foot of soil is going to be about 6 inches. Now you're going to cut it in half again. The rule of halves, you're just going to keep cutting it in half, which is pretty nice because you can just remember to do that. So if you have 6 inches of saturated soil water, then the next rule of halves is going to be 3 inches, and this is what we're going to call field capacity. This is what happens after gravity takes some of this away after the first day. So if it was a massive rainstorm just came through and the soil is fully saturated at 6 inches, this is called gravitational water. Over the next 24 hours after that rainstorm, you're going to be losing this water to gravity. It's going to be pulling it down to the soil, and you're going to be left with 3 inches of field capacity water. So the next half down here is what we call plant available water, we'll say PAW. That's plant available water right there. And that basically just means that this is the water that your plants actually have access to. Anything below this, due to the physics and everything with water and the adhesion and cohesion, the water is going to be stuck so much to the soil particles that your plants aren't going to be able to access any of this water. So that's off the board. So now we're only focused in this area that the plant can use. You're going to cut that in half again. And I'm going to do a dotted line right here. And the upper half of this little pie, slice of pie, is called the MAD water, which is the maximum allowable depletion water. that's what you're going to use when you're calculating ET and when you're calculating your irrigation schedule. So you can go from field capacity all the way down to the mad water before you need to irrigate again. And I'll show you how to do that in a little bit. But then after you go below this line of mad water, your plant is going to be stressed. So that's the maximum amount you can allow to deplete before your plants become stressed. In this zone, your plants are stressed, but they're still getting a little bit of water, so they aren't dead yet. Once they get below this, your plants are getting zero water. Your plants are going to die. So you don't want it to ever get below that. But you want to irrigate when it gets to the mad water line. So for example, the mad water in this scenario, if you cut it in half again, the plant available water is 1.5 inches, and the mad water is in between that. So let me just do some quick math. E plus 1.5 divided by 2, 2.25. Yeah. So with that, the way I found this number, if you want to find the mad water number, what I like to do is I just like to take the average of the field capacity and the PAW, the PAW. So I just did 3 plus 1.5 divided by 2. That's the average of those two. It's going to get you the number that's in between both of those, which is 2.25 inches. So that's a little side note, but we're going to go back to calculating the ET. So now let's say you have an ET of 0.21 inches per day. And once again, the ET is just a calculation of how much water the plant is actually using each day. And it's going to be specific to each crop, but for these practice problems, we're just going to use kind of random numbers. So to calculate ET and how frequently you're going to need to irrigate, you're going to want to find out how much water is in this area. So you're going to take 3 and you're going to subtract 2.25. That's going to leave you with 0.75 inches. So we have 0.75 inches of mad water. I'm going to highlight this real quick just so it's a little easier to see. This is what we are caring about right here. This is mad water, and that is mad water. We have 0.75 inches of mad water. Now what you're going to do is you can take this number and you can divide it by that number. And that is going to give you how many days you have before you need to irrigate. So let's say you just watered your grass and you filled it up to field capacity. You have 3 inches of water in your soil right now. How long before you need to water your grass again? What you're going to do is you're going to take 0.75. I'll write it down so you can see. 0.75, and you're going to divide it by 0.21, which is the ET from here. And that's going to give you 3.57. So 3.5 days before you should be watering again, which means really you could round up to 4 days usually, because like I said, when it gets past here, your plants are a little bit stressed, but they're still fine. They really get in trouble when they're like at the bottom of that range. So if you push that back another half day, it's not going to really be too big of a deal. Or you can just adjust this 3.5 to whenever you like to irrigate. So if you want to irrigate in the morning, like lots of people do, then just whatever is closest to the morning time, push it to the next morning or to the morning before. That's what I would do. So yeah, this just shows though, if this was your soil, people leave their sprinkler systems on and they irrigate every single night. You're overwatering. You're paying for too much water. You're using too much water. It's bad for the environment, and it's actually not as good for the roots. If you follow this pattern here, you're going to encourage your grass to grow a little bit deeper roots, and that'll help them to be a little bit more water efficient and, just be a little bit better off. And this is also, it's kind of tricky to do, water based on mad water, if you don't have a good irrigation system, or if you're using different types of heads in the same zone, or you're not getting, uniform water put out onto your lawn. If that's the case, you're going to have dry spots because your watering is only good in some spots and not in other spots. So it's important to make sure that, in your sprinkler zones, all the heads are spraying correctly, and that basically all spots of the lawn are getting pretty equal amounts of water. Obviously, you're going to have some overlap areas, but you don't want to have any one spot that's getting way less than every other spot. And that makes it so that you have to water till that spot's green, which means every other spot on your lawn is going to be getting too much water. All right. So that's basically the rule of halves. If we want, we can try another practice example. I'm going to change this, and let's say it's 0.18. I don't know. We'll just make that up. Let's say you have a foot of soil, but your root depth is only 6 inches. So you take a core sample, you look at the dirt, and you can see that the roots only go to 6 inches deep. They're not going the full foot that you calculated for before. So you have 6 inches total right here. That means you have 3 inches of soil, and you have 3 inches of pore space. You have 3 inches of soil and 3 inches of pore space. You cut that in half again, you have 1.5 inches of field capacity water. This is all gravitational water, so you have 1.5 inches of gravitational water. That's going to mean you have 0.75 inches of plant available water, and that means you'll have, I'm going to take the average of those two numbers and figure out 1.125 inches of mad water. And that's your mad water. So what we're going to do is, if you want to, you can pause right now and see if you can figure it out on your own. I'm going to keep moving on though. Okay, let's say we're going to calculate this. After a full rainstorm and you're fully saturated, how long before you should water your lawn again? All right, let's get going with that. 1.5 minus 1.125, that's going to give you 0.375. And you can take 0.375 and divide it by 0.18, which is going to give you 2.08, which is just going to round down to 2. So you have 2 days before your mad water runs out. But that's not what I said, and that's what we're going to calculate. Is we said you have the full saturation. You just had a massive rainstorm come through. You have 3 inches of water. How long do you have before you water your grass again? What you're going to do is you're going to take this answer that you got, and you have to add an extra day for gravitational water, because it takes about 24 hours for that to deplete. So 1 day here, and then you have 2 days before the mad water runs out. That's going to equal 3 days. So we're going to take that 1 day. You're going to have 2 days here. You have 3 days before you water your grass again. Yeah, that's pretty much it. I might do one more example with you guys just for fun, and this will be a little bit more complicated. Each time we're going to get a little bit more complicated. Let's say this is for class. If you're in class and you get a problem like this, then this is going to be what it's kind of about. Let's say it's going to give you, for every foot of water, you have 4 inches. For every foot of soil, you have 4 inches of water. But your root depth is, let's say your root depth is 6 inches again, just for fun. You're going to cut this number in half. You're not going to be using the rule of halves based on the full foot of soil. It's giving you that you only have 4 inches of water for the foot. So now we kind of don't really need to worry about this. You just have 4 inches of water for the whole foot, and you need to cut that in half because you only have 6 inches. You divide by 2, you get 2 inches. 2 inches of water for this 6 inches of soil. All right. So from here, you cut it in half again. You have 1 inch. You can cut it in half again. You have 0.5 and 0.75. And let's say it's kind of cold. It's maybe late fall and the ET is not very high. Let's say you have an ET of 0.12. Let's say, once again, you have the fully saturation rain event that happens. How long before you need to irrigate again? So you're full. You're all the way up to here. How long before you water your lawn? If you want, pause it and work on it on your own, but here we go. 1 minus 0.75 is going to be 0.25. 1 minus 0.75 equals 0.25. You can take 0.25 and divide it by the ET, 0.12. That's going to be about 2 days, but just to be sure, yeah, 2.08, which is going to be 2. And then you need to remember to add on the gravitational water, which is another 24 hours. That's a third day. So plus 1, you're going to get 3 days. Once again, sorry I chose numbers that gave you another 3-day answer, but that's how long you have before you water again. Hopefully this helps. I don't know. I was kind of confused myself a little bit there. It's kind of different doing it on my own versus like trying to teach it. So that's good that I'm learning it again. But yeah, sometimes if they just give you the amount of soil you have and it won't give you like a number for water, in that case, just use the rule of halves and say like half of it is pore space and half of it is soil. If it does give you a number that's like, maybe it's usually going to be a little bit less than half. It'll be like you have a foot of soil, and for every foot of soil, you're getting 3.75 inches of water or something like that. That's not exactly half. That's less. So you're just going to use this number here for the top. And you might need to divide it by 2 if it's like you have a foot, but you only have 6 inches of roots. Or if you have 4 inches of root depth, let's see. Let's say it was 4 inches. Let's just do that for fun so that we're all on the same page. So you have a foot, and every foot of soil you have 4 inches of water, but your root depth is only 4 inches. So it's going to be easier if you move that to inches, I think. 12 inches of soil gives you 4 inches of water. You're going to divide 4 divided by 12 is 0.33, which is also just a third. So you can multiply this by a third or times it by 0.33333. It'll get you the same answer. 4 times by 0.33333. That means that instead of 2 inches of water, you actually, for your root depth and for your root zone, you only have 1.33 inches of water, which will affect your watering schedule as well. So it is important to pay attention to the root depth, because anything below the root depth, you're not going to be able to get to your plant, so you can't calculate that as part of your irrigation schedule. So pay attention to that number. Pay attention if they give you values for the per foot of soil. And yeah, that's it.